In many ways, this is one of the most basic topics that we can actually study, because if I was to draw kind of like a little rectangle here, and I was to say to you, for example, men, in fact, let's start with women. Women require, on average, 2,000 kilocalories per day. So this is, on average, this is the sort of the calorific consumption by women. If I was to draw the equivalent thing over here, I'll try and get my rectangles roughly the same scale, not too bad. We could look at the same principle for men, and we'd be looking at 2,500 kilocalories per day. In fact, let me put that in there, per day, and I'll write the same over here. And this is a guide, okay? It may well be that some days you consume far less than this, other days you consume more, maybe not far more, far less. I suppose maybe a Christmas day you might consume far more depending on your background, but this is a guidance I want to make. Now, before we get into what is the very basic concept of energy balance here, I just want to make sure we understand what a calorie is, okay? Now, I don't think this is going to get examined for you, but let's imagine I drew some Bunsen burner. Here's my Bunsen burner, and at the top of this Bunsen burner, there's the sort of the here's my Bunsen burner here. Here's my Bunsen burner, and at the top of this Bunsen burner, we've got some kind of flame. Okay, so we've got some kind of flame here. All right, so we've got my Bunsen burner. I want to imagine that there is a kind of a tripod maybe round the outside of this with a gauze on top, and just above that flame, we've got a little vessel, and inside that vessel, we have got 1 gram of water. Well, a calorie, and I'm talking about a single calorie, is the amount of energy or heat required to increase 1 gram of water by 1 degree Celsius. That's what a calorie is, okay? So, if you consider this kilocalorie, this is exactly the same concept, but we are saying this is how much heat or energy is required to increase 1,000 grams of water by 1 degree Celsius. In other words, a litre by 1 degree Celsius. So all of a sudden, that kilocalorie is not an insignificant amount of energy, okay? That's what a calorie is, and it's useful just to be aware of that. I'm so sorry about my drawings. I know they're absolutely terrible. I'm just trying to get the principle across to you. Now, with that in mind then, let's put a scenario in place. Let's assume, let's talk about a woman, for example. Let's say that we have a woman. We won't give her a name, but we'll call her woman number 1. Okay, and let's assume for a second that woman number 1, she consumes during week 1 or for a week's period, she consumes 2,000 kilocalories per day, that consumed. And let's imagine that that is equal to the 2,000 kilocalories that this person spends. What would we expect from this person's body weight? So they are effectively consuming the same number of kilocalories that they spend through metabolism and movement. This person, we could summarize, would have a stable weight. Would you agree? Now, we're not talking about this over an individual day, we're talking about this over a period of time. Let's change this scenario. What about if we said woman number 2, let's go for this one, woman number 2. Let's imagine that she actually spends a little bit more than 2,000 kilocalories a day. She actually spends 2,700 kilocalories spent, because maybe she's training in the gym or she's performed in a football match or whatever, but she still consumes 2,000 kilocalories. Sorry, but I shouldn't have put this symbol in here. What I should have done here is not had that at all. Not equal, but she's now consuming 2,000 kilocalories compared to the 2,700 that she spent. And this is over a period of time, remember. So in this situation, this individual would lose weight. Okay, over time, of course. What if we had woman number 3, and this time woman number 3 had a different relationship, woman number 3. What about if she was consuming a large number of calories, let's say 3,500, maybe this person is, eating stuff that they shouldn't be, they're maybe in a period of time where they're comfort eating or whatever, and they're only spending their 2,000 kilocalories spent. Okay, in this scenario, this person would of course gain weight. So the point I want to make here is twofold. First of all, we can simply say consuming more calories than you spend will gain weight. Consuming fewer calories than you spend will lose weight. Consuming the same will lead to stable weight. But just notice that there are two variables. We can consume more or less, and we can spend more or less. And sometimes we sort of forget that. It's just like, oh, well, I just eat less, or I'll eat more, whatever. No, we are talking here about matching one's calorific intake into one's energy expenditure. So, key principles for me: training or exercise or physical activity. Okay? Absolutely critical for human beings, and if we do that, whilst it's not a case that we can just eat as much as we want or drink as much as we want, it is the case that we will of course require more calories, so we perhaps need to be a little less cautious about how much that we do eat. The other thing I would say in here is think about the impact of a sedentary lifestyle. Think about someone whose basically energy spent keeps going down. What does that mean? Now, I'll give you an example here. For 17 years, I was a practical active PE teacher, and then I started working effectively in an office. I had to reduce my calorific intake to match that decrease in expenditure. Now, I did that in a couple of ways. I didn't do it very successfully to begin with. And of course, I've replaced the exercise I was doing at work with other forms of exercise: cycling, going to the gym, whatever it happens to be, walking on a regular basis. But these two variables are variables worth considering. Thank you.